Small drones for military use are being leveraged beyond short-range reconnaissance. Draper develops detection capabilities for chemical, biological, radiological, and nuclear CBRN elements, so that military units can send sUAVs ahead to scout location and identify hazards without risking personnel. Previously, detection of CBRN elements may be performed using handheld or vehicle-mounted sensors, explains Draper. Customers are asking, can a sUAV sniff out these CBRN hazards in place of humans? How smart does a sUAV need to be to search, map and locate these CBRN hazard without a remote operator? When a sUAV encounters a building or obstacle, can it fly in and around it safely? These are just some of the questions our team is exploring. Kim, Draper Program Manager, said. The Joint Program Executive Office for Chemical, Biological, Radiological, and Nuclear Defense CBRN has funded the Draper program, called CBRN Sensor Integration on Robotics Platform. The team investigated the customer needs through field observations, noting requirements such as sensor efficiency and resolution, flight speed, height, duration, autonomous operation, sensor-driven mapping, networked command, and enhanced situational awareness through shared interactive digital maps, says the press release. In addition to search, detection, and mapping of CBRN hazards, soldiers also need totally autonomous flight, including obstacle avoidance, potentially in GPS-deprived environments. Soldiers dispersed across an area also want a way to share information that is secure, networked, and mapped to the environment, the release points out. The new capabilities Draper developed for CBRN take advantage of multiple environmental inputs, along with a sensor fusion algorithm that can synthesize data from instruments including GPS, LiDAR, inertial measurement units, magnetometers, and cameras. All that fused information is designed to achieve robust and autonomous operation through the use of new algorithms developed for CBRN that make the sUAV capable of obstacle detection and avoidance. Mobile military technologies, like sUAVs, can be force multipliers and force protectors at the same time, Kim said. Anytime you can deploy technology like a sUAV to detect suspected CBRN hazards remotely and operate independently without exposing a soldier unnecessarily to harm is an advance in warfighter systems, and that's important to us at Draper. Draper designed the autonomy framework and sensor-driven mapping algorithm to be an extensible, modular, and resilient mobility platform that is vehicle and processing system agnostic, said Julius Rose, Associate Director for Sensors and Delivery at Draper. As new capabilities and vehicles are developed, autonomous systems should be readily adaptable to support numerous mission types across domains, be that air, ground, or sea. Development needs to be efficient, reusable, and agile to keep up with the pace of the needs of soldiers and personnel in the field.